Good day, kids. You're welcome back to mathematics class. My name is Olubaya Marilyn Kende, and today we're going to be looking at the second part of angles between lines and triangles. If you can recall from the last class, we talked a lot about angles between lines. We said that we have corresponding angles, alternate angles, co-interior angles, supplementary angles. We said that when a transversal crosses between a pair of parallel lines, alternate angles and corresponding angles formed are equal. But we also said that it is possible for a transversal to cross between a pair of non-parallel lines. And when this happens, the angles formed, that's the alternate angles and corresponding angles formed, are not equal. Well, today we are going to be focusing on angles in a triangle. Now, by the end of this lesson today, you should be able to apply the angle sum property of a triangle and exterior angles of a triangle to calculate unknown angles in a triangle. Simply meaning, by the end of this lesson today, you should be able to calculate angles in a triangle. Now, straight away, we are going to be looking at angles in a triangle. What is a triangle, first and foremost? A triangle is the simplest form of a polygon. I'm very sure we know what a polygon is. A polygon is a plane shape with 3 or more sides. A polygon's shape has at least 3 sides. Now, triangle is the simplest form of a polygon because it has 3 sides and 3 interior angles, okay? Tri meaning 3. So triangle means 3 angles. Very simple. Now, there are different types of triangles. We have the scaling triangle. A scaling triangle is a type of triangle that has no equal sides and no equal angles. Now, isosceles triangle is a type of triangle that has just 2 sides equal. While an equilateral triangle, from the name, you can see that it has all its 3 sides equal and the angles formed are also equal. Now, acute angle triangle, this type of triangle has each of its sides less than 90 degrees. We have obtuse angle triangle and right angle triangle. Of course, the type of triangle that is 90 degrees. Now, interior angles. Now, to properly understand interior angles, we're going to do some class activity, okay? Now, you are going to get a cardboard paper. You are going to draw a triangle shape on your cardboard paper and label it A, B, and C, just like we've done here. Now, when you do that, you're going to cut out the triangle, okay, from your cardboard paper. You're going to cut it out along its sides. Then, you're going to make 3 angles from that triangle. You're going to give it an angle in A, B, and C. Now, after doing that, you are going to turn it inverse. You are going to turn it upside down, okay, to make it straight underneath. All right, so at the end of the day, you're going to have C and A in a straight line. Now, when you form this shape, you would see that everything, all the angles we've cut out are on a straight line, therefore proving that angles on a straight line, which from previous discussion is 180 degrees, proving that A, B, and C make angles on a straight line, which is 180 degrees. Thus, to show that the sum of angles in a triangle is 180 degrees, now we're going to prove the practical we just did. Now, you're going to draw a triangle ABC. These are our triangle A, B, and C. You're going to draw a line LM through the top vertex. Remember vertex? We're going to draw a straight line L and M through the top vertex of triangle A, B, and C. Now, this LM is going, of course, will be parallel to line BC, okay, which is the base. Now, you label the angle as shown in this diagram, okay? You label the interior A, B, C, D, and E. Okay, now from this diagram, we're going to be drawing some observations. Now, if you look at this diagram, you will see that B and D are alternate to each other. Remember what we said about alternate angles. Now, if you look carefully, you also see that C and E are also alternate to each other. Now, alternate angles are equal. That is what we've been learning in the past lesson. Alternate angles are equal. So B and D are alternate angles and C and E are also alternate angles. But now, A, D, and E are on a straight line. Angle A, angle D, and angle E are on a straight line. Now, pay close attention. What did we say about angles on a straight line? We said their sum is 180 degrees. Okay, so we can say that A, B, C, D, and E will give us 180 degrees because they are all angles on a straight line. Hence, the sum of angles in a triangle is 180 degrees. I hope you understand. Now, let's look at the exterior and interior opposite angles. Exterior and interior opposite angles. Now, look at this triangle ABC. Now, if you look at this triangle, you will see that we have an angle outside and it is labeled X. Now, if you look at this X, you will see that it is opposite to the angles inside, to the angles AB inside the triangles, meaning X is opposite to the interior angles A and B. Now, to show that X is equal to A and B, to show that X is equal to A and B, we are going to draw a line at C. This is our C. This is the same triangle we had before. We are going to draw a line at C. Draw it here. Okay, we are going to call it CD. We are going to label it D. We are going to separate it D and C. Now, when you do that, the line is going to be parallel to line A and B. This is A and B. Of course, this line, this CD, is parallel to A and B. Now, from this diagram, we can see that A and D are corresponding angles. Where is our A? This is our A. And this is our D. Remember, we said about corresponding angles. We said they are equal from previous lessons. Look at it very well. Are you seeing the shape formed? A and D are corresponding angles. In like manner, B and C are alternate angles. B and C are alternate angles. Alternate angles are also equal. Okay? Now, from this, we can say that X, the angle formed here, which we splitted into D and C, is equal to C plus D and A plus B. I hope you understand. I want to take it all over again so we would really get it. Now, this was our X. This is our X. Okay, now we splitted it into two to get D and C. All right. Now, if you look at this very well, you see that A and D are corresponding. Okay, and we said corresponding angles are equal. Now, if you look at B and C, you will see that they are alternates. And alternate angles are also equal. So we can say that C plus D is the same as A plus B, and hence we can say that exterior angle of a triangle is equal to the sum of the interior angles of a triangle. I will take it again. The exterior angle of a triangle, that's the angle outside of a triangle, is equal to the sum of the interior opposite angles. Remember, this is opposite to this. So the sum of this is equal to the exterior angle. I hope you understand. I hope you are following. Now, let's take some examples to further buttress this point. Now, we're asked to find the size of angle X in this triangle. Okay, we're asked to find the X in this triangle. This is just sum of angles in a triangle, and we've said that is 180 degrees. Now, to do that, you are going to take your X plus 64 plus 88 equals to 180 degrees. Now, when you sum 64 and 88, you get 152. Now, to get X, you just do the subtraction and you get 28 degrees. Now, number 2. In the diagram below, find the value of A and use the answer to find the actual value of the interior angles. Okay, we're asked to find the value of A here and get the actual values of these angles. Now, first of all, to get this angle, vertically opposite angles are equal, like we've learned before. Okay, so this angle formed here is 2A. All right. Now, this angle is 2A. Now, to get the actual value and the value of A, first of all, we are going to first of all get the actual value of A. So 2A plus 3A plus 4A is 180 degrees, which is the sum of angles in a triangle. Remember, this is angle 2A. Now, when we sum this, we're going to get 9A. Now, to get the value for A, we'll just divide 9 by 180 degrees by 9, and we'll get 20 degrees. Now, if A is 20, we'll just substitute A into these angles to get the actual values. Then 2A will be 2 times 20 to give us 40, and 3A will be 3 times 20 to give us 60 degrees, and 4A, 4 times 20 to give us 80 degrees. So therefore, the actual values for these angles are 60, 80, and 40 degrees. Number 3 example. 3 angles of a triangle are 4x degree, 4x minus 2 degree, and 3x plus 6 degree. Now, we're asked to find the value of x, number 1. Then B, we're asked to find the largest angle. Now, how do we go about this? We've said that in any triangle, the sum of angles in a triangle is 180 degrees. Hence, 4x plus 4x minus 2 plus 3x plus 6 is 180 degrees. Simple simultaneous equation. We just simplify this and we get 11x plus 4 equals to 180 degrees. Now, we collect like terms, okay? We make 11x subject of formula to do. We are trying to make x subject of formula now. So, we move 4 over to this side, simply collecting like terms. Okay, 180 minus 4 will give us 176 degrees. Now, to make x subject of formula, we divide 176 over 11. Okay, now when we do that, we have x as 16 degrees. Now, B, we're asked, let's look at the question very well. We're asked to find the largest angle. We've gotten x, now we're asked to find the largest angles. Okay, so the simple equation we're going to do, the simple thing to get the largest angle now is just to substitute the value of x. Okay, we've gotten x as 16 degrees, so we'll just substitute x into the different values. Okay, substitute x here, here, and here to get the different angles and get the largest. Now, 4x will now be 4 times 16. Okay, 4x will now be 4 times 16. Remember our value for x, 16. And when we do that, we're going to get 64 degrees. Then 4x plus 4x minus 2 will be 4 times 16 minus 2, which is 64 minus 2, which will give us 62 degrees. Then 3x plus 6 will be 3 times 16 plus 6, which is 48 plus 6, to give us 54 degrees. Therefore, the angles in the triangle are 64, 62, and 54. Just merely looking at it, we'll know that the largest angle is 64 degrees, which is 4x. Now, number 4 example. If AB is a straight line, find angles x and y. Okay, this is our straight line AB, and we're asked to find the values of x and y. So to do that, we'll just make use of our exterior angles theorem, which says that the exterior angle is equal to the interior opposite, is actually equal to the sum of the interior opposite angles. Now, these are our interior opposite angles, so 38 degrees plus 52 degrees plus 46 degrees, and to give us 136 degrees. Now, to get x, we just divide 136 by 2, and we get 68 degrees. Okay, so we've gotten our x. Okay, we've gotten our x. Now, to get y is just going to be y plus 46 degrees equal to x, and using the exterior angle theorem. Now, if we do the sum, we are going to get 22 degrees as our answer. Now, example 5. Find the size of angle x in this figure below. Okay, this is angle x. We're asked to find the value or the size of angle x. Now, we can see that angle BAC is 75 degrees. Why? Because vertically opposite angles are equal. This is our angle BAC, okay? This this is the angle BAC here. Okay, are you seeing it? So these two, as we can see, are vertically opposite. So 75 degrees is angle BAC. Now, angle BAC and plus angle BCA plus X, okay, is 180 degrees. This is angle BCA. BCA. This is angle BCA is 50 degrees. Okay, and we just got angle BAC as 75 degrees because vertically opposite angles are equal. Okay, the angle is going to be here. So it's 75 degrees. So to get value for X is just going to be 75 degrees BAC, 50 degrees BCA, and X equal to 180 degrees. When we take the sum, we're going to have 125 degrees plus X equal to 180 degrees. When you subtract 125 from 180, you are going to get 55 degrees, meaning the value of our X, or the size of our X, is 55 degrees. Now, example 6, given that AB is equal to BC, okay, given that AB is equal to BC, and angle CBD is 28 degrees. Okay, this angle CBD is 28 degrees. We're asked to find the sides of angle A, B, and C. That is this angle. All right, we're asked to find the value of angle A, B, C. Now, CBD is 28 using the isosceles triangle has two sides equal. Okay, so CBD is 28 degrees. All right, and ACB, these are ACB, that's this side, is equal to X. We are going to use the X is equal to angle, is also equal to angle CBD because the exterior angle, because of the exterior angles theorem, which says that the exterior angle is equal to the sum of the interior opposite angle. So we can just say that CBD is also 28. So we are going to have 28 plus 28 degrees plus 28 degrees is 56 degrees, which is angle ACB plus angle CBD because they are both equal. Now, in triangle ACB, triangle CAB is equal to triangle ACB, and ACB and CAB are both 56 degrees, which is the sum of 28 and 28. Remember, we said they are equal. Okay, now a triangle ACB is 180 degrees because some of the angles in a triangle is 180 degrees. So 180 degrees minus 56 plus 56. When we add 56 plus 56, we are going to get 112. Okay, 112. Now, 112 taken away from 180 degrees will give us 68 degrees. Okay, so we can say that the size of angle ABC is 68 degrees. So the size of angle A, B, and C is 68 degrees. I hope you understood that. Number 7 example. In the diagram shown below, PQ is parallel to RS. So we're asked to find the value of angle A. Okay, we're asked to find the value of this angle. Now, to make it simpler, we're going to relabel this diagram. Okay, we're going to get another angle B here. Okay, and we're going to get an angle C here. Okay, now B is vertically opposite to this angle. So we can say that B is equal to 54 because vertically opposite angles are equal. And also, we can say that C is also 54 because if you look at this shape, you will see that these angles are corresponding. B and C are corresponding. So C is 54 degrees. Now, to get the value of A, we just subtract 54 plus 40, 54, which is C, from 180 degrees. Okay, to get the value of A. Remember, we're trying to get the value of A in this triangle. Okay, and the sum of angles in the triangle is 180 degrees. So simply, we subtract 40 and 54 from 180 degrees. And when you do that, you get 86 as your answer. I hope that was clear. Now, we're going to take some evaluations to see if you've understood all that we've learned today about angles in a triangle. Now, number 1, calculate the third angle if angle PQR is P equals to 70 degrees, Q equal to 75 degrees. So in this place, we're looking for angle R. And B, if angle P is 68 degrees, angle Q is not known, and R is 95 degrees. So here in B, we're looking for angle Q. Number 2, we're asked to find X in this triangle. Okay? This is the right angle triangle. We have to find the value of X. Number 3, we have to find the value of C in this diagram. Okay? C is an exterior angle, so you know what to do. Number 4, we're asked to find the values of angle A, B, and C. Number 5, find the angles marked P, Q, and R. Number 6, if PQ is parallel to MN, okay, if PQ is parallel to MN, find the sizes of angles X, Y, and Z. I'm going to give us a few minutes to do these evaluations. Now, solution. In this question, we're looking for R, and we all know that the sum of angles in a triangle is 180 degrees. So very simply, it's going to be 75 plus 70, 75 plus 70 plus R equal to 180 degrees. When you take the sum, you have 145 degrees. When you subtract that from 180, you are going to get 35 degrees. So R is 35 degrees. B, just the way we've done this, we're just going to add it and sum it up to 180 degrees, subtract the sum of these angles from 180 degrees, and get our Q. Our Q here is 17 degrees. Number 2, very similarly to what we've done before, except that this angle was not given. But if you look at this, you will see that this is a right angle triangle. And you know that an angle at right angle is equal to 90 degrees. So just like what we've done before, we'll add it up and sum it up to 180 degrees. Then we'll subtract the sum from 180 degrees to get our X. Our answer is 550 degrees. C, this is what we are looking for. Okay, we have to find the value of C. If you look at this, you see that C is an exterior angle, and from what we've learned, we said that an exterior angle is equal to the sum of interior opposite, is equal to the sum of the interior opposite angles. If you look at this, you will see that C is opposite to these interior angles. Okay, so very simply, you will just sum the interior angles, 28 plus 35 degrees, and you will have your answer as 62 degrees. Therefore, C is equal to 62 degrees. If you got that correct, please put your hands together for yourself. Number 4, we're asked to find the value of A, B, and C in this diagram. We have to find the value of A, B, and C in this diagram. First of all, to get the value of A, we're going to sum everything to 180 degrees. Why? Because the sum of interior angles equal to 180 degrees. The sum of angles in a triangle is equal to 180 degrees. So 32 plus 90 plus 32 plus A equals to 180 degrees. You sum it up, you subtract the sum from 180 degrees, and you get A as 58 degrees. Now for B, the sum of angles on a straight line is 180 degrees. I hope you remember that. If you look at this, you will see that these two angles are on a straight line. Okay? These two angles are on a straight line. So their sum is equal to 180 degrees. So we have A as 58 degrees. Okay, so 58 plus B equals to 180 degrees. To get B, you subtract 58 from 180 degrees to give you 122 degrees. So in essence, B is 122 degrees. Now C, let's look at the diagram again. C, this is our C. We're looking for C. Now C is equal to we're going to use the sum of angles in a triangle formula. Okay, we've gotten B. We have 30 here. Now to get this, we're going to sum all this to 180 degrees. Now, when you do that, you have C plus 122 degrees plus 30 degrees equals to 180 degrees. Now, when you sum 122 plus 30 degrees, we have 152. So simply, we'll subtract 152 degrees from 180 degrees to give us our C. So therefore, C is 28 degrees. If you got that correct, please put your hands together for yourself. Now, number 5, we have to find the value of P, Q, and R. Okay, P, Q, and R. Now, if you look at Q, you see that it's vertically opposite to this angle. So we can say that Q is 130 degrees because vertically opposite angles are equal. And R, to get R, we're going to be making use of the exterior angle theorem, which says that the exterior angle is equal to the sum of the interior opposite angles. So, very simply, R plus 38 is equal to 130 degrees. This angle is exterior to these angles, R and 38. So to do that, to get R, we just subtract 38 from 130 to give us our R, which is 92 degrees. Now, for P, we're also going to do the same thing, which is add everything and sum it up to 138 degrees, which is the exterior angle. Okay, which is the exterior angle. Now, this is a right angle triangle. Okay, this is a right angle triangle, and we all know that a right angle triangle is equal to 90 degrees. Now, so we are just going to add 90 degrees plus P and sum it up to 130 degrees. Now, when we do that, we are going to get the sum as 40 degrees. When we subtract 90 degrees from 130 degrees, we are going to get P as 40 degrees. Now, number 6, we were asked to find the value of y, x, and z, of x, y, and z if line QP is parallel to MN. Now, if you look at this very well, you see that there is a straight line here. There is a straight line. So angles on a straight line is 180 degrees. So first of all, we're going to get our Z. Okay? Now, these two angles are on this straight line. These two angles are on this straight line, not this straight line. They're on this straight line. So the angles on a straight line are 180 degrees. So Z plus 115 degrees will give us 180 degrees. To get our Z, simply subtract 115 from 180 degrees to give us 65 degrees. Now, to get X, we do the same things. We sum X, we sum everything up to 180 degrees. Okay, when you take the sum of 265, you get 117. Now, to get X, we'll just subtract 117 from 180 degrees to give us X as 63 degrees. I hope you understood that. We've learned a lot today about angles in a triangle. We said the sum of angles in a triangle is 180 degrees, and we said that the exterior angle is equal to the sum of the interior opposite angles. I hope you have learned today. Okay, we've come to the end of the lesson. See you in my next class. Thank you very much.